All right, we're in Unit 3, Day 3 notes. The title is Quadratic Functions, Standard Form. We've already done vertex form and intercept form. We're going to talk about standard form today. So this first part says finding the maximum and minimum using the calculator. I know the calculator is a little bit difficult to get to. Maybe you were able to download it onto your computer. If you did, just a reminder on how to get the maximum and minimum in your calculator. You would type in the problem into y equals. You would look at the picture. Then you would kind of assess what your picture has. It either has a maximum or a minimum. And then you would hit second, trace, and then you would select max or min. I'm just going to write max or min, depending on the picture, right? Because it depends what your picture looks like. So we've done that before. That's in the calculator. The other method, which I'm going to just show you very briefly, is Desmos, which is just a website. So I'll show you that in just a moment. So this next problem, this is where I'll show you. It says find the maximum minimum using the calculator or using Desmos. Does the graph open up or down? So problem 1. F of x equals x squared plus 2x minus 6. It is a positive in the very beginning, positive x squared. So that means it opens up. So that means my graph looks something like this little graph, which means that down here at the bottom, somewhere I have a minimum. Okay, so this is where I'm going to show you. I already went onto Desmos. I just searched Desmos. I clicked that first link when I type it into Google. I type the equation over here on the left into my Desmos calculator, and it does the graph right for me here. And I noticed that my minimum, the lowest value, if you could see my cursor, I just kind of hover over that and it gives me the point. You could count it if you wanted, but the point is at -1, -7. So I'm going to go back to my notes here. My point, my minimum is at -1, -7. And let's look at problem 2. Problem 2 is negative x squared minus 2x plus 8. It has a negative x squared in the front, so that means it's opening downward. It looks something like that downward facing graph, which means I have up at the top there, I have a maximum. I'm not going to show you because we don't have a ton of time for these videos, but if you were to go back to Desmos, take away the old stuff, put in the new equation, or type this into your calculator, whatever you have available, your maximum would be -1, +9. Okay, graphing in standard form, that's what we're talking about today. So here's a reminder, standard form is y equals ax squared plus bx plus c. Okay, two things to know about standard form. The first thing is that it tells you really easily your y-intercept. Your y-intercept comes from the c value. So your y-intercept is going to be 0, comma c. And let me highlight that blue for you. So see that c value? That's where you're going to get that from. The other thing that we're going to do is this is going to help get our vertex. So we're going to use this equation, x equals negative b over 2a. And let me highlight, b is the number on the inside, kind of in the middle, and a is the number from the front. So I highlighted those yellow and green so you can see where those go. Okay, we're going to use that x equals negative b over 2a, and I'll show you how right now in this example. So here's my example, -1/2 x squared minus x plus 6. It wants to know first what form this is in. This looks just like the form we just talked about, which is standard form. Okay, to find the vertex here, this is where I'm going to use my equation. So I'm going to do x equals negative b over 2a, and let me plug in. So b is the number like in the middle here, next to the x value, and in this case, the b value is a -1. I already have a negative sign in the equation, so it's technically a -1. And then the a value is the number in the very front, which happens to be a fraction. So I have the 2 times the -1/2. So -1 becomes a +1. So let's write that. And then on the bottom, 2 times negative 1/2 is negative 1. Then just doing that division, negative 1 goes into positive 1, negative 1 time. That is the x value of your vertex. Okay, you then need to take that x value and you need to take that and plug it in to your original problem. So see how everywhere in my original problem where there was an x, I put negative 1 in that spot. And you could take that, since it's just a bunch of numbers, this whole chunk right here, just a bunch of numbers, you could take that and type that into your calculator, type it into Google, whatever, and get your number. It should be 6.5. And that is your y value. So this work right here where I just squiggled gets you your vertex. From your vertex, you can get your axis of symmetry. So x is equal to negative 1. Remember, those always match up. I'm highlighting those green. Max and min. This graph is a negative 1/2 in the front. That means it opens downward. Remember, if it opens down, it looks something like this. So there's no minimum. The maximum happens to be the same point as the vertex. So negative 1, 6.5. Remember yesterday I talked about x-intercepts are going to be a little bit difficult, so we're going to skip over that. If you wanted, you could put this into Desmos, and you could get the x-intercepts. That's kind of a nice way. The y-intercept is the next part here. The y-intercept is 0, comma the c value. The c value is the number, let's use a different highlighter, I'm going to use orange, is the number on the end of your equation. So the c value is 6, so 0, 6. And I'm going to take a moment and I'm going to put that information on my graph. So I know that my vertex is at negative 1, positive 6.5. I'm going to put my point on there the best that I can. And then I have my maximum, okay, that's already on there, and my y-intercept is at 0, 6. And I need to put my axis of symmetry on there as well. So again, I know mine's a little bit hard to see. I'm writing with my finger, but you can go ahead and put your points in there. I know that it opens downward. So my graph is going to look something like this. My increasing interval is going to be over here on this left side where the yellow is. It is increasing from negative infinity until that axis of symmetry, which is at negative 1. It is decreasing on the other side, the blue side. That is from negative 1 to positive infinity. This next part, I know I keep saying other classes maybe didn't do it. It's the end behavior. Both of the ends of the arrows are pointing downward, so we write negative infinity. The domain is the x value, so it forever goes to the left and it forever goes to the right. The range is the y values. It goes down low forever, and the highest that it gets is 6.5, and that's a number, so it gets a bracket. And that one's finished. Let's do another one. Okay, so here's my problem, x squared plus 6x minus 2. I'm going to go ahead and state the form. This is what we're doing today, standard form. I want to first find the vertex, so I'm going to use my equation, x equals negative b over 2a. B is the number in the middle by the x value, so that is positive 6. So I have negative, and then I put the 6. And then the a comes from the number in the front. The number in the front for this one is technically a 1. So I have negative 6 over 2, which ends up giving me 3. So that means the x value is negative 3. I'm then going to go ahead and take this problem, and anywhere I see an x, I'm going to put a negative 3 in that spot. I'm just typing that or writing that in. There's a whole chunk with just the numbers here. You could type that into your calculator, type it into Desmos, anything like that, even your cell phone, and you can get negative 11. That is the y value. So this helps you with the axis of symmetry. X is going to be equal to negative 3. Remember, those match up. Minimum and maximum, it is a positive in the very front of your problem, so that means it opens up. If it opens up, that means there is no maximum, and the minimum is going to match that vertex. So those are going to be the same. Again, x-intercepts are a little bit tricky. We're not going to do that. You could type it into Desmos. You could type it in your calculator if you downloaded it. That's just a little bit extra practice. Y-intercept, this is the nice part for standard form, is going to match the number on the end. So the number on the end here, I'm highlighting it green, is -2. So my y-intercept is 0, -2. I'm going to take a moment, put all those on my graph. I know this is going to run off a little bit. -3, -11 is going to be kind of off my graph a little bit, but I'll do my best I can there. 0, -2, and then my axis of symmetry is at -3, so I'll put that in there. And then I know that this graph opens up, so it looks something like that. So increasing and decreasing, my graph is increasing over here on this yellow side. It increases from that axis of symmetry, which is at -3, all the way until positive infinity. And it decreases over here on this blue side, decreasing from -infinity to -3. The next part again is the end behavior, which some of you have done. The end behavior, both of the arrows are pointing up, so that's positive infinity. My domain is the x values. It forever goes to the left. It forever goes to the right. My range is the y values. The lowest this graph gets is -11. It's a number, so it gets a bracket. The highest is positive infinity. Okay, let's finish with some quick problems here. So, first one, it gives you the equation. It wants to know the form. Problem A is in vertex form. It is negative in the front, so it opens down. If it opens downward, you have a maximum. If it's in vertex form, you can tell the vertex and axis of symmetry very easily. You do the opposite of the inside, the same as the outside. Axis of symmetry is going to match that x value. The next one, this looks like what we did yesterday. This is what we call intercept form. Intercept form tells us the x-intercepts. We'll do that in a moment. It is a positive 1/3, so that means it opens upward. If it opens upward, we have a minimum. The x-intercepts, remember we took each piece and we set each piece equal to 0 and we solved. So the first x-intercept is at -3, 0. And the other x-intercept, I have to do both of them. The other x-intercept I set equal to 0 and I solve, and I get 2, 0. All right, last one here. My last one is kind of what we just did is in standard form. It is a positive in the front, so it opens upward. If it opens upward, it has a minimum, and the really quick thing we can find here is the y-intercept, which would be 0, -7. -7 from the back of the equation. Remember to check on the Canvas site to see what your assignment is. Maybe you have the exit slip, but I would recommend doing the worksheet first, making sure you perfected that. Ask your teacher if you have any questions, and then move on to the exit slip. You don't want to rush the exit slip.